So in the previous lesson 7, we actually go through how to design a controller, alright? And then in L6v4, we actually go through with you how to test the controller. Alright, so after you design, you can test the controller. And then you can also remember that we actually test for the controllability of the controller. We can also test for the observability of the controller. Alright? And therefore in this video, or in this series of lesson, we'll talk about the how to design an observable controller. An observable controller, and then you can test for the observability of a controller. So in this such of the case, we'll start to design a controller that can observe real model systems. Alright. Therefore, the purpose of this video is to introduce you with the concepts of how to model an observable controller, because there are a few points that you may need to consider before you design a controller. Alright, and the 3 points are, which is the first one, it requires that all states has to be measured. Alright, all states has to be measured, because if you want to observe certain things, you need to observe everything, right? Alright, if you want to design whatever observable stuff, you need to know how that particular thing works. Alright, so in order to design based on whatever you see, correct? So however, this is unrealistic requirement, because you cannot model all states. Alright, all states means what? If you remember your x over here, this is your x. If I were to bring it over here, is your x. Your x is equals to, it's not just x itself. It can be many x. It can be x1, x2, x3, all the way to x infinity. Okay, these are all your states. And if you're dealing with time, then you're talking about xt. When xt is equals to, when time is equals to, for example, 1, right, you have some values. At x2 you have some value all the way to x infinity. Where there is no x infinity, there is no time towards infinity, although you can test it for very long, but you cannot take in all states, because all states means all the states of the system, which is not cool, right? Also, there is also disturbances going on. Alright, so therefore your states can be maybe distorted or what. Alright, and the states graphically, alright, you may have x1, x2, x3, all the graph you can observe. You can see how the graph move and everything based on your inputs and wherever. So therefore you can see all the states. Alright, so I just want to convey to you this understanding. Alright, and the last one is, and therefore, alright, the third one is that estimate the states from the available measurement. So instead of measuring all states, we can measure the things that we can see. Alright, so we can somewhat predict the trend. Right, as we have shown you over here, if you have x1, then you have x2, x3, all the different graph all lies in this region, or you have some outliers, maybe like x54, x100 state, the 100th state, or the 54th state. Alright, there are outliers over here. So you know that the most of the states lies in this region. So therefore you can somewhat predict your model. Alright, because you observe that most of the system's output lies in this region, and therefore you can design based on this outcome to your whatever thing that you want. Okay, so this is just a brief discussion on how to design a system. So therefore, after knowing and observing the trends, then you can estimate how the trends will move, right? And therefore you can design your things. So therefore the observer and the estimator are often used interchangeably, because when you observe already, you can estimate how the trend goes, right? Which is what we have shown you. If you have all the x1, x2 all the way over here, you can estimate that your model should somewhat lie in this region. Your output should somewhat lie in this region, unlike the outliers over here. Hope that this is pretty clear. Or if you don't understand what the outliers means, is that, for example, you have 100 states, alright? Most of the states lies, you have all so many states lie in this region. Maybe you have only 2 states that lies outside this region. Alright, this region over here has 98 states. Alright, that means you have x1, x2 all the way to x98. You have all the trends all over here. But maybe one or 2 states, alright, have other values that spikes up or whatever. But however, in this region you can predict your stuff. So you can estimate your system. And therefore when you observe, you can estimate. I hope this is pretty clear. Hence, in the next series of the videos, alright, we will discuss about the open loop. As you can see, your U, alright, your U is going to input into your processors and output into your controller. Alright, and then you have a certain output from your controller. Okay, this is a one-way ticket, open loop. Okay, nonetheless, alright, this is for the real system. Nonetheless, you will have a U that is go into your estimator, your model, something that you want to model. Alright, so that you can design your controller, right? Because you observe already, then you want to model the wherever you want to observe. Okay, so we can call this the model or estimator. Alright, and it has its own output. Okay, so you compare the real output to your designed output. So you design your output already, you see whether is it correspond to your output from the real system. Okay, by inputting the same stuff. Alright, hope this is pretty clear. And therefore this is a comparison between two open loop systems. Okay, so if you were to, because after you compare already, alright, you want to know what is the differences, and then you can adjust accordingly. So you will need a feedback system, and there will be a closed loop. And this is just the meaning, the general meaning of things. Alright, and I'll go into details later on. Alright, but in this case, I'll just leave you to this understandings, open loop or closed loop. But before I go to the next video, I just want to inform you that in order for the model, which is this one, and the processors, this one, in order for both of their outputs, which is at over here, to be the same, the only occurrence is when you're talking about initial condition. Only if their initial conditions are known and the disturbances are 0. Okay, so these are the two things that you may also want to remember. Okay, initial conditions are known and the disturbance are 0. Because because if you have disturbances, you actually cause your y and this y over here to always have difference. Because you have your disturbance within your own system, you also have disturbance within the processor system. So therefore the disturbance actually cause your system to be haywire or something like that. Okay, so therefore you have to take note of these things. Alright, so in the next video we shall go through the open loop system. Alright, and I shall see you there. I see you.